Welcome to the ICLR Friday Forum for August 26th, 2022. I'm your host, Dr. Keith Porter. I'm the Chief Engineer at the Institute for Catastrophic Loss Reduction. This is one in a monthly webinar hosted by ICLR, Canada's leading source for disaster resilience knowledge. Each month, we present recently completed research related to ICLR's mission to make Canada more disaster resilient. Today, I'm going to tell you about ICLR's aims to provide disaster resilience knowledge about hailstorms. This is an unusual Friday forum in which one of the ICLR staffers presents our research, but this one is interesting, so we thought you might like to hear about it. Before I give you my presentation, I want to remind you of our agenda. Our program today will last an hour and 15 minutes rather than the usual hour and 30 minutes because of a conflict that I've got a little bit later on today. I will speak for about 30 minutes, maybe 40 minutes, and then we can have Q&A for the balance of the time. We will post links to the deck that I'm presenting today, to the video that's being recorded now, and we'll post those things today or Monday. The deck itself has links to the documents I'm going to mention here. All right, so with that, those preliminaries out of the way, let me introduce the topic of my presentation today. In 2021, ICLR began a study of how homeowners and insurers can save money by preventing hail damage using impact-resistant asphalt shingle roofs. And today I'm going to tell you how that study concluded after feedback from many of our members. The headline of that research is that society saves up to $8 in avoided future losses per $1 of cost, and insurers, by the way, save up to $3 per dollar spent considering retention rates. The motivation here is that hail is among Canada's most expensive natural hazards. It costs almost $400 million annually. A June 2020 hailstorm at the edge of Calgary damaged 70,000 homes and cost $1.3 billion. A direct hit on Calgary could be 5 or 10 times worse. That's a very costly natural disaster. And although that hailstorm is inevitable, the catastrophe, the economic catastrophe, is not inevitable. Much of the losses that we see in hailstorms come from roof repairs. You can see in this picture, these little chalked circles indicate damage to roof shingles. This is in the Norman, Oklahoma hailstorm of April of 2021. We can reduce or prevent a lot of that loss by using impact-resistant asphalt shingle roofs instead of standard shingles. They look the same, but the impact-resistant ones have a special material that makes them resistant to damage. In fact, you can take 51mm steel balls like this, each weighing half a kilogram, and you can drop them from a height of 6 meters, like the height of a 2-story building, onto a shingle without damaging the shingle. And that's like the strongest impact by the biggest hailstone in 99% of storms that you can do with these, resist with these shingles. Now, in order to estimate the costs and the benefits of these asphalt resistant shingles, we actually had to create an entirely new analytical methodology. I'm an engineer, so I used engineering techniques, a new technique that fits into the broad framework that engineers call performance-based engineering. And unlike most of what structural engineers do, we use building codes, and sometimes we use pass, no pass, or graded ratings. This performance-based engineering framework allows us to do some pretty neat things. We can estimate the behavior of a system, an asset like a building, in terms that people care about. Repair costs and life safety impacts and loss of functioning, or as I call them, the 3Ds, dollars, deaths, and downtime. We can treat all of the important sources of uncertainty in this analytical framework. We can avoid reliance on expert judgment, and we can make interesting business claims about design choices without having great big piles of actuarial data on the system, on the performance of whole systems, hundreds or thousands or tens of thousands of buildings in past hailstorms. We do this by creating models, mathematical models that are built from bite-sized pieces of the whole process, rather than just collect a whole bunch of data. Here are 10,000 houses, and this is how many hailstones hit each one, and here's the repair cost. We build up our mathematical model from individual pieces that are more tractable. We start by defining the asset at risk, a particular house, or a few particular houses with particular square footage and material and so on. And then we can add in information about what nature does to that asset, how frequently hailstorms occur, and how big the stones are, and what density they fall with, and so on. Then we calculate what the environment, what nature does to the building. We calculate building forces and building deformations using fancy structural and analytical models. So that's not so important in hailstorms, but it's important in other engineering studies like earthquakes and what wind does to buildings. Then we can put the information about what's happening to the structure and what nature is doing to the parts of the building into models that calculate the damage. How likely is it that a wall will be torn apart, or that a roof shingle will be blown away, etc. And then once we have a model of the physical damage, we can estimate the consequences of that damage in terms of dollars, deaths, downtime, or other interesting measures of the performance of a building or some other engineering system. When we put all of that together with some very fancy math, we can inform some decisions that you cannot otherwise inform. We can create really strongly defensible benefit cost analyses, for instance. That's what I'm talking about today, to tell you what's the likelihood that you're going to have a storm that destroys your roof, and what's the likelihood in a given period of time, and the expected present value of future losses, and all sorts of interesting business questions that you can't answer with a building code. A building code tells you whether you have passed basic safety requirements. It doesn't tell you what the consequences of complying with the building code are in terms that you might care about, like dollars, deaths, and downtime. So unlike building codes and most rating systems, we can estimate that those behaviors and those terms of interest. We can measure all the important sources of uncertainty. When will the storm happen? And what, is it likely that hailstones would damage a particular shingle, etc. We can avoid recourse to expert judgment. We, as I mentioned before, we don't have to wait and have a great big pile of actuarial quality data on the behavior of the whole system. We build it up from bite-sized models, and each one of those bite-sized models we can improve incrementally. The meteorologists are constantly improving our knowledge of how frequently hailstorms will occur. We have a project with the Institute of Catastrophic Loss Reduction has a project right now with Western University in which Western engineers are out in Alberta collecting hail data. They observed Canada's largest ever hailstone just a couple of weeks ago. And from that data, we are going to be able to improve our model of what the environment does, what nature does to the buildings. So anyway, by these little improvements to the pieces of the model, we can improve the whole model and make better assertions about, like, the business case for code improvements, or the business case for building back better after a disaster. When we implemented all this, this performance-based hail engineering method, we were able to estimate the costs and benefits of hail mitigation, at least this one thing about replacing ordinary shingles with asphalt, with impact-resistant asphalt shingle roofs. And here's what we found. First, impact-resistant shingles add about 50% to the cost of a roof. And for the average roof, that's about $3,400. But in many places, the shingles save more than they cost. Impact-resistant shingles reduce the chance of damage by 15 times. And if the roof is damaged, the average repair cost drops by half. As a consequence, in Calgary, considering how frequently hailstorms happen, the shingles save $10,000 over the 20-year life of the roof. That's a benefit cost ratio of 3 to 1. The shingles pay for themselves in 5 years on average. An insurer with a 90% retention rate would save $4,200 over the life of a policy in Calgary. Now, there are places with twice as many hailstorms as Calgary gets. In those places, society saves more than twice as many. In those places, society saves up to $8 per dollar of cost, and insurers save up to $3 per dollar of cost. And that's ignoring cases where an insurer inherits an impact-resistant roof that a prior insurer paid for. So the inheritor of a roof, of a policy where somebody else paid for the impact-resistant shingles, the insurer doesn't pay for it. The benefits flow entirely to the insurer. Or if you are a homeowner and you're not carrying insurance, or it's not adequate, the homeowner gets those benefits. Now, those costs and benefits scale up or down with roof size, and obviously location matters. Places with more frequent hailstorms get more benefit, and less frequent hailstorms mean less benefit. And of course, the size of the roof matters. Bigger roof, more cost, more benefit. Smaller roof, less cost, less benefit. Now, let's talk about the parts of an asphalt shingle roof, just so you know what's going on under this roof. The little circle number 1 shows roof joists, and they're spaced between 400 millimeters and 600 millimeters apart, and they hold up the roof. That number 2 there is structural sheathing, like plywood or oriented strand board that's might be 8 millimeters thick or 16 millimeters thick. It's nailed to those roof joists with 2.5-inch long nails spaced about 6 inches apart at the edges, and 12 inches apart in the middle of the panel. One tacks on top of that structural sheathing, that number 2. Number 3 is an underlayment of asphalt saturated paper, weighs 0.19 kilograms per square meter, or 90 pounds. That's 90-pound paper. Or you can tack on number 15 asphalt saturated felt, and that serves as a supplemental moisture barrier, and it also prevents adhesion between the roof sheathing and the shingles that are just above it. The underlayment is optional in some codes and standards, and mandatory in others. So number 3 will appear on some roofs in some eras and not on others. The top layer comprises the shingles, and overlapping layers of shingles. These are nailed to the roofing deck with 4 or 6, 10 or 12 gauge galvanized nails per shingle, and adhered to the layer below with factory applied heat activated sealant bands. As the shingles age, it's common to add a layer of new shingles, up to 3 in total on steep roofs, without removing the old layers. Doing that avoids the cost of removing and disposing of the old layer, but it can introduce a couple of problems: an uneven surface and reduce fastener strength, and that can reduce the life expectancy of the new layer. And then there's other potential problems as you add layer after layer. And in some cases, you have to add eave protection, such as felt underlayment from the roof edge to 900 millimeters up the roof slope. When you zoom in closely on the asphalt shingles and sort of cut a cross section, it sort of looks like this little diagram here. That cross-hatched layer in the middle, that's a fiberglass mat, and that serves to shed water and to adhere the ceramic coated crushed rock particles. They're called granules. Oh, I'm sorry. I'm sorry. I beg your pardon. Number 1 is a fiberglass mat that provides the shingles strength and stiffness. Numbers 2 and 3 are the asphalt layer. that sheds water and is there to adhere the granules that are number 4. There are in that layer, there's finely ground fillers or mineral stabilizers in the asphalt that improve the asphalt's fire resistance and its flexibility and its durability and its resistance to weather. Number 4 is these granules. They coat the upper surface of the shingle, and they provide its color, and they protect the asphalt from ultraviolet light, which degrades the asphalt. And on the back surface of the shingle, that number 5, that's coated with a fine mineral that prevents the shingles from sticking to machinery during manufacturing and sticking to each other while they're being stored. So in order to estimate costs and benefits, you have to drill down and find out what is it going to cost to put on these asphalt shingle, these impact resistant asphalt shingle roofs, as opposed to non-impact resistant asphalt shingle roofs. I told you that the cost is $3,400 for the average size roof, or here I've rounded it to $3,000, but there's a wide range of lines of impact resistant and non-impact resistant shingles. This is part of a big table in our study that says, here's the price for this product, and this is where we found this price, and it's a price per roofing square, per 100 square feet of roofing material. And the table goes on and on with all the different products that we were able to find published prices for. We, as part of this process of developing performance-based hail engineering, we had to create mathematical models that related the size of the hailstone that hits the shingle to the chance that a single shingle will be damaged. And the damage takes a couple of different forms. It can be purely cosmetic, where it knocks off a bunch of granules and you can see these nasty looking bruises, or it can break the shingle, so breaking the moisture barrier, allowing water into the roofing and into the attic. And oftentimes those two things kind of go together. They tend to happen at about the same time. You hit a shingle with a hailstone strong enough, and it will both create a bruise and break the moisture barrier. This set of fancy curves here just relates the size of the hailstone that's on the horizontal axis with the chance that you're going to break the individual shingle that's on the vertical axis. And there's 4 curves there, and the one labeled 4, for instance, says that this point right here says that if you hit that shingle with a hailstone of about 80 millimeters diameter, there's a 50-50 chance that class 4 shingle will be damaged. And you can take this model and you can scale it up to the entire roof, so that with some knowledge about the density of hailstones and the distribution of hailstone size, you can estimate, if this is as a function of the storm's largest hailstone, biggest diameter hailstone, the average fraction of the roof that you're going to have to replace. With that knowledge, you can go to cost estimation software like Xactimate or other cost estimation tools and estimate the repair cost. And the repair cost involves a whole bunch of steps. It involves demolishing and replacing the underlayment, the material, the labor, the material and labor to demolish and install the shingles. And those costs have low, moderate, and high values. There's a range. We were able to estimate a total cost per square and a marginal cost per square and so on to do the actual repairs. You put all of this stuff together in a fancy mathematical model, and you can find that where in Canada impact resistant shingles save more than they cost. In this map shows the savings, the places where impact resistant shingles are cost effective at a societal level. That is, when you add up all the costs and all the benefits, both to today's owner and future owners and so on. Any place that's shown in yellow here, the total benefits exceed the total costs. That is much of Canada. It's not just not just near the Rockies, but across a lot of Canada, even today, there's enough hailstorms to make impact-resistant shingles cost-effective in all of these places. And of course, as climate change takes stronger grip over the next 20 years, that'll make future hailstorms worse. It will increase the value of having impact-resistant shingles, because it'll mean that ordinary roofs are going to be more likely to be damaged and more heavily damaged, which means that if you've already switched to an impact-resistant roof, the more frequent the storms, the more you are going to save through avoided future losses. If you only consider the insurer's perspective, the insurer might have a policy where the homeowner has just put on a new impact-resistant roof, and that insurer will get all the benefit of avoided losses over the next year during the policy period, and then with a 90% chance or so, maybe give or take, that policyholder will renew next year, and that impact-resistant roof will continue to provide benefits to the insurer next year. And then there's a 90% chance or so that the insured will renew again, and so on. So when you add up all those 90% chances, these are the places where impact-resistant shingles are cost-effective for the first insurer. If the first insurer were to pay for the marginal cost to go to impact-resistant shingle. Now, again, this ignores the case where you are a subsequent insurer and a prior insurer or the prior homeowner paid for the strong roof. This map shows where the shingles are most valuable. The light blue means that the shingles just pay for themselves on a societal basis. Green means the shingles save 3 times what they cost. Yellow means 5. Red means 8. And at a 90% retention rate, the first insurer gets about 40% of what we're seeing here. And later insurers get the rest, assuming that the house is continuously insured over the life of those impact-resistant shingles. This map shows that 40% of the benefit cost ratio that the first insurer enjoys. The color scheme is the same. So light blue means the shingles pay for themselves. If the insurer were to pay to put up the impact-resistant, the marginal cost of the impact-resistant shingles, those shingles will pay for themselves in terms of avoided future claims. Green means a 3-to-1 benefit cost ratio, and there's a little spot of yellow in there where an insurer would get a 5-to-1 benefit cost ratio. Here are some first products of our hail resistance studies. These are the ones having to do with the study I've just told you about. There is we offer a 4-page overview. That's the image on the left, and there's a 66-page detailed report. That's the image on the right. I'll give you the URLs for both of those reports toward the end of this slide deck, but they are free to download. You can learn all about all the assumptions we made, all the models, etc. In short, we found that protecting a home from hail makes financial sense across much of Canada, including to insurers who only get a part of that benefit. So please see our webpage for more information about ICLR's Hail Smart program and about this performance-based engineering study, the work that we've done so far. But we are not yet done. We have a long-term research program. There are many questions about the costs and benefits of different kinds of hail mitigation. And ICLR means to pursue that long-term research program. We want to know about the costs and benefits of protecting vehicles, for instance, using those canopy-like garage structures that you can buy for a few $100 at a home supply store. We want to know the costs and benefits of changing siding as Canada perhaps adapts to increasing wildfires. We may want to increase the resistance of our siding, such as by using hardy board. What is that going to save in terms of reduced hail damage? Or conceivably, different siding will be cost effective just because of its hail resistance. What about solar panels? There have been some tests that say that solar panels are impact resistant to hail storms. We'd like to see if there are see if we can strengthen the case for that through laboratory testing of solar panels and other kinds of roofing. What about metal roofing? What about slate and other types of roofing? How impact resistant are they? We're going to pursue this long-term research using a new experimental setup. You're seeing a picture of it on the right. That's a metal box, and the thing that's sticking up out of the top of that mesh metal box is a tower that's 6 meters or 20 feet tall. Now, going up the center of that tower is a transparent tube, 3 inches in diameter. Those sort of reddish things that you can barely see hanging off the tower, those are cords. And what we can do, and hanging down through the middle of that tube is a cord, and on the end of it is a magnet. We can put a steel ball on that magnet, anything up to a couple of inches in diameter, and we can hoist it up that tube, and we can, when you pull it far enough, the ball drops down into the cage. And when it hits the bottom of the cage, it's got about the same kinetic energy as a hailstone of about the same diameter. So a steel ball dropping 20 feet produces about the same, transfers about the same amount of energy onto a target that a hailstone dropping from hundreds or thousands of feet does. So we can sort of simulate the effect of dropping hailstones onto a thing from hundreds of feet high with this much more manageable 20-foot tall tube and steel balls. And we can put in that mesh cage anything we want. We can put in a piece of windshield glass, or a piece of vinyl siding, or a piece of a solar panel, or some other kind of roofing, and we can vary the angle of the test specimen, the angle that the steel ball hits it at, and we can examine the change in the chance that we're going to break the thing if it's a steep roof or a shallow roof, etc. So that that's how we're going to keep going with this this research into hail resilience. Now, all of this it's not about producing journal articles and getting our name spread out there. This is really all about how to make change, how to make Canada more resilient to hailstorms. And we're doing that basically 3 different ways. We're doing outreach like this to spread the word that impact resistant roofing is cost effective, and here's where it's cost effective, and here's where it isn't, basically making the case that impact resistant asphalt shingle roofs can be cost effective. We're also working with a building official in Calgary. He's formulated a code change request that uses our benefit cost analysis as justification for requiring impact resistant shingles, at least in some places. And a third way that we are helping to bring about change is that through our Insurers Rebuild Stronger Homes program, we're hoping that some insurers actually offer insurance coverage where they will pay for the added marginal cost of impact resistant shingles. So, most insurance historically insurance has repaired stuff like for like. So you have a ordinary shingle roof and it's damaged by a hailstorm. Well, the insurer's obligation, according to the policy, is to replace that roof with something that's just like it. And the problem is that doesn't reduce the problem. And as hailstorms become more and more frequent, it simply re-injects liability to the future. So we've made the case here that even if the insurer pays for the added cost to go to a higher grade of roof, that insurer is actually going to get a benefit for it, just purely in terms of the reduced claims, not even counting claims adjustment costs. So this is how we're trying to make change with the study that I've just presented to you. Now, if you want to learn more about the study, or you want to tell others about it, there's a one-page meme. There is a 3-minute YouTube video. Here's a link to that 4-page non-technical summary, very digestible, very easy to hand off to colleagues and friends. And if you really want to see the gory details, you can download that 66-page technical report. And again, I'm going to post this deck to our website. That'll go up today or Monday, so you'll be able to see these links today or Monday. And with that, I'm going to conclude my presentation, and we can have some Q&A. If you have questions or you want to make a comment, why don't you type that into the Q&A box, and I'll read the questions. And if if the question is long, just say you'd like to give the question verbally, and we can unmute you and you can ask your question. Any questions, any discussion, comments, advice? We'd love to hear your advice on how to use this information to bring about change or to help member insurers, and so on. Okay. So Scott Davis asks, he says, thanks for sharing the mapping. Have we extended it to Eastern Ontario? No, sadly. I have shown you the extent of the mapping that we can do with the available hail hazard information. That's the extent of the country where we know how frequently hailstorms happen. As that knowledge about hail hazard improves, we'll be able to extend, as that knowledge extends to Eastern Ontario, we'll be able to extend the map to Eastern Ontario. Francis asks, what motivated or financed this initiative from ICLR, and was the insurance industry and or shingle manufacturing industry implicated in some forms? So the motivation, it basically comes from ICLR's mission. Our mission is to help Canada become more disaster resilient. Now, the financing also came from our, it was not nobody financed this particular study. We just decided that we wanted to do it. And with our normal operating budget, I set aside the time, I did the analysis and published it as just part of what we do. So insurers sort of indirectly paid for the study because they provide much of our funding. But nobody said, here, I'm going to write you a check and go off and do the study. It wasn't like that. And ditto, we didn't have any involvement from the shingle manufacturing industry. So nobody said, please go out and hype my impact resistant shingles and I'll give you $1 million for that. So this was really just as innocent and done for the public good as I've tried to make it out to be. Cindy asks, when you calculated the cost, did you also include the potential increase in premium based on the claim happening? No, the cost as I calculated it here is just the marginal cost to pay for the higher, pay for the more expensive roof. So the perspective, the cost and benefit perspective, imagines that one person, like the insurance company or the homeowner, pays for the roof, and let's say it's the insurer pays for the roof, pays for the added cost of the roof, and what's the benefit that comes back to them. So they don't have a cost in terms of higher premium. It's just, the premium during the next year is the premium during the next year. Now, if another perspective, the one that leads to that 8-to-1 benefit cost ratio is, suppose you were a homeowner that was going bare, you don't have insurance, you build the roof with this better shingle. Here's the cost, the marginal cost to do the better shingle, and here's the benefit that you're going to enjoy. Let's imagine that you're this imaginary homeowner who doesn't have insurance and is going to own that home for the life of the the roof the next 20 years or so. So that's that 8-to-1 perspective. And then from that perspective, again, the premium doesn't matter because in my assumption, there's no insurance premium. So basically, we don't get to the level of detail about how much more am I going to pay as the homeowner for insurance. Francis asks, says, thank you for the information. Are you looking to see if a class 4 shingle is still hail resistant after 10 years? That's a great question. The assertion is that shingles, they age and their impact resistance might change. You will see evidence in the report about why we don't think that's going to affect the benefit cost ratio information. I'm going to switch over to, I see there's another question in the Q&A, but I also saw a couple of questions come into the chat. So I'm going to look over in the chat box. Joanne asks, what would be the cost savings for the 2020 Calgary hailstorm if the houses had impact resistant shingles of the 2021 Calgary hailstorm? That's a great question, and I wish I could answer it. This was purely long-term probabilistic. We didn't do a study of how much the loss would have been reduced in that big hailstorm. But we do know that the frequency of claims drops by 15 times, and the severity of claims drops by half. So we can probably do the math with just those two numbers and the $1 billion loss figure. Ian asks, do we have any input on synthetic roofing materials, for example, F-Wave products? No, I'm sorry, I don't know about synthetic roofing materials other than the synthetics that are embedded in the asphalt in the existing in those existing products that I listed. I actually only showed you part of that table. Scott Davis asks, following your presentation, I understand that further research is required on steel roofing. Do I estimate that hail-resistant asphalt shingle roofs may provide more bounce and can absorb hail better than denting steel roofing? I wish I knew. I haven't actually studied the damageability of steel roofs. That's sort of what I would like to do, what we would like to do, perhaps over the next coming period of time, a year or more. And I don't even want to guess about which one's going to be better, which one's going to be worse. We know that in many cases, a policy is going to cover the performance of the steel roof, where performance is measured purely in terms of its water resistance. So it could be the case that you've got a steel roof, or you insure somebody with a steel roof, and there's a big hailstorm and it dents the heck out of the roof, but the policy does not cover aesthetic damage as long as it doesn't penetrate, puncture the water resistance. Many policies, maybe most or all, are just going to say, I'm sorry, we told you in advance that aesthetic cosmetic damage isn't covered. So you're just going to have to live with a dented roof. We're going to have to replace it. In any case, we're not paying for that. Francis asks, in Canada's most severe hailstorm area, are insurers paying or incentivizing class 4 shingles with premium reductions? And would this report have an impact on expanding or establishing premium reductions for homeowners to install class 4 roofs? As far as I know, no one is providing, well, I'm sorry, I'm not an expert in, how everybody's doing their pricing. So when I say I'm not aware of anybody reducing their premiums, if they know about class 4 shingles, don't read anything into that. That doesn't mean that nobody's doing it. It means that I'm ignorant of it. Would this report have an impact on expanding or establishing premium reductions? Absolutely. That's why we put out the information about the benefit cost ratio. That's why we put out the information about reduced frequency and severity. I think that I think there's enough information in this report that actuaries can establish a defensible premium reduction for a class 4 shingle roof. I simply don't know. I haven't talked with anybody who's actually done that yet. Cindy asks, how do we determine the areas that would have a payback? Did we use hailstorms in the past, or do we have forecasting data? It's, in a sense, it's both. We have records of hailstorms, the frequency of hailstorms across all the places where that map showed colors for the last 20 years or so. So we know for all those places approximately how many hailstorms per year there are, and we know from other information, hailstone size and whatnot. So we can use that hazard information, and I glossed very quickly over the math that you have to do to go to create those areas of payback, but it's called the theorem of total probability. If you know the probabilistic damage given a hailstorm, and you know how frequently hailstorms occur, you can estimate the average annual loss with the impact resistant shingles and without, and for anywhere. So if you know that the second part, the loss given a hailstorm, is constant, and you have a map that says here there are this many hailstorms per year, and there are that many hailstorms per year, you can put those two things together and calculate the benefit cost ratio for this, that, or the other location. In any place that benefit cost ratio is greater than 1, that's where there's a payback. Benefit cost ratio just means the ratio of the benefit, that is how much money you're going to avoid losing in the future, divided by the cost, that is how much more you have to pay for the impact resistant shingles in the first place. And you do some present value calculations just like economists do when they your lender does when he or she calculates a mortgage payment, and you can calculate the present value of those benefits and divide by the present value of the costs. That's the benefit cost ratio. Anywhere the benefit cost ratio is greater than 1, that's a place where the investment is desirable. It's going to save more than it costs, and those are the places that were shown in yellow on that initial map where there's a payback. Scott Davis says thanks for the responses. You're very welcome. Any other questions that we would care to ask? Anything you're curious about the study, or where we plan to go next, or advice about where we ought to go next? Well, hearing none, I guess we're going to conclude a little bit early. I want to alert you that next month we will have another Friday Forum. We might even have 2 Friday Fora. We just came up with a second speaker. So if we have 2, the 2 will be on wildfire paths and on this the research that University of Western Ontario has been doing for us for ICLR on hail in Western Canada. You will hear about the collection of a record-breaking hailstone picked up a couple of weeks ago in Alberta, and you'll learn about what ICLR is doing to better understand the hail hazard in Western Alberta. Watch for our advertisements, just like you saw the advertisement for today's talk. Watch for the advertisements for one or both of those Friday Fora next month. And with that, I will give you back 45 minutes of your day. Please feel free to reach out offline if you care to hear more about this the study or what ICLR is doing for hail resilience. Thank you very much.